Hi everybody, this is a video on section 11.4, operations with radical expressions, and the different types of examples we're going to be focusing on are combining like radicals, simplifying to combined like radicals, and using the distributive property. So our first example is 13 times the square root of 2 minus the square root of 2. So we have like radicals, which are the square root of 2. So what we can do is use the distributive property to combine 13 minus 1, because remember there's really a 1 right outside the square, just square root of 2. So we can pull those down and it'll be 13 minus 1 out front of the square root of 2. And that simply just reduces to 12 times the square root of 2. Our next example is a little bit more challenging, but still just we're using the same kind of concept. We see that they're all three of these terms have the square root of 5 in them, which means that they are like radicals. So similarly to the last example, we can combine 7 minus 2 plus 3 out front of the radical, just using the distributive property. And 7 minus 2 plus 3 is 8. And the square root of 5 can't be reduced anymore, so it's just 8 times the square root of 5. Three says, tell whether each pair of expressions can be simplified to like radicals. So what we want to do is we see that the square root of 2 can't be simplified anymore, so our goal is to see if we can simplify the square root of 98 into a square root of 2. So right away you can see, or hopefully you can see, that 98 is 2 times 49. So, and this is all underneath the radical sign, so we know that 49 is a perfect square, so we can pull the 7 out front, and the 2 can no longer be reduced, so it's just going to remain the square root of 2. And then, as you can see, they are like radicals because they both have the square root of 2. For this example is focused on using the distributive property. So first we want to apply 3, the square root of 3, to both terms inside the parentheses. So first we want to apply the 3 to the square root of 3 times the square root of 6, and the square root of 3 times 2 times the square root of 15, as demonstrated right here. So we know that the square root of 3 times the square root of 6 is going to give us the square root of 18, and the square root of 3 times 2 times the square root of 15 will simplify to 2 times the square root of 45. But we want to make sure that these are completely simplified, which they're not, so we want to look for perfect squares within 18 and 45. We can see that there is 18 is a split of 9 and 2, and 45 is a split of 9 and 5, and 9 in both cases is a perfect square, so we can pull the 3 out in front of both of these. So 18 is going to simplify to 3 times the square root of 2, because our 2 is simplified, so that stays underneath, is as simplified as it can get, and 5 will remain underneath the radical since the square root of 9 is 3. So now you just want to go ahead and multiply 2 times 3 to simplify this even further. So now our final answer will be 3 times the square root of 2 plus 6 times the square root of 5. And this can no longer be simplified anymore. We cannot combine these two terms together because they are unlike radicals and not like radicals. Five is the square root of 7 plus the square root of 63. And our first thoughts should be 63 has perfect squares, and that is going to split into 9 and 7. 9 is our perfect square, so we can pull out the 3 in front of the radical, and the 7 remains inside. And since we're adding these two terms together, we just bring down the 7 since there was nothing we could do with it in the first place. So now we have the square root of 7 plus 3 times the square root of 7. And this goes back to the first example. Since these are like radicals, we can combine them and use the distributing property. So 1 plus 3 out front of the square root of 7 will just give us 4 times the square root of 7. Our last example is 8 times the square root of 5 plus 6 times the square root of 45. And 8 times the square root of 5 is simplified, so we can't do much with it at this point. But 6 times the square root of 45, we should see that 9 is a perfect square within 45, so it's 9 times 5. So we can pull the 3 out front of the radical, and the 5 will remain in. And our 6, we just pull that down since there's nothing we can do with it when we're simplifying this. So we're going to have 3 times 6 out front of the square root of 5, which will give us 18 times the square root of 5. And we just continue to bring down 8 times the square root of 5 since this was simplified from the beginning. So now we have like radicals, and we can combine the terms out front. So 8 plus 18 will give us 26, and we carry down our square root of 5 since they're like radicals. So our final answer will be 26 times the square root of 5.